These are notes on the metric system and converting between units, both within the metric system and outside the metric system. Some of this is going to be review to you, and some of it is going to be new. So for the metric system, go ahead and draw a line, and then we're going to put in the various prefixes that you need to be responsible for in this class. So slightly towards the left, not directly in the middle, go ahead and put in the basic unit. And that is the meter, the liter, the gram, although there are other ones. You've heard of gigabytes, for example. Byte there is the basic unit, and giga is the prefix. You've maybe heard of microseconds, or not, I'm sorry, milliseconds. You know, people say it happens in a millisecond. That is actually 1/1000th of a second. So you can have other basic units, but the ones most of us are familiar with right now are the meter, liter, and gram. These are then the prefixes most of you have been taught in previous science classes, from kilo to hecto to deca. Then you have your basic unit, then deci, centi, and milli, with deci, centi, and milli being smaller than the basic unit, and kilo, hecto, and deca being larger than the basic unit. And each one being 10 times smaller or larger than the one in front or back of it. So we say kilo, 10 to the third, that's compared to the basic unit. So 10 to the third is 1,000, meaning a kilo anything, say a kilometer, is 1,000 times larger than a meter. Or, said in the opposite way, there's 1,000 meters in 1 kilometer. A milli, we say, is 10 to the negative 3, meaning it's 1/1000th the size of a basic unit. So a millimeter is 1/1000th of a meter. Or it's you could say there's 1,000 millimeters in a meter. So those are the ones you guys are most familiar with. Let's add in a new one. On the larger scale, at 10 to the 6th, or a million times larger than a basic unit, is the prefix mega. So if you've heard of megahertz in wave frequency, some of you have heard of that, or megabyte in computers, the hertz and the byte are the basic unit, and the mega stands for a million times larger than the basic unit. So a megameter would be a million times larger than a meter and 1,000 times larger than a kilometer. Or you could say there's 1,000 kilometers in a megameter, or a million meters in a megameter. Obviously, we don't really use megameters because it's such a large unit, but you could, and we'll see mega in other things. There are units in between kilo and mega, just like there are units in between the basic unit and kilo, but we don't use them a lot, and so we're not going to worry about what those are. We tend to go within magnitudes of 1,000. So going down on the smaller side, 1,000 times smaller than a milli is a micro, and that's 1/1,000,000th of a basic unit. So a lot of you who took biology last year used micrometers, and you measured out microliters. A microliter is 1/1000th of a milliliter and 1/1,000,000th of a liter. Said another way, there are 1,000 microliters in a milliliter and 1,000,000 microliters in a liter. And then you could even say 1,000,000,000 microliters in a kiloliter, or 1,000,000,000,000 microliters in a megaliter. So you can convert between different units, and it's pretty easy based on the thousands, because we go 1,000, 1,000,000, 1,000,000,000, 1,000,000,000,000. I don't know what comes after trillion. 1,000 times smaller than a micro is a nano. And you've probably heard the prefix nano before. Basically, we use it in everyday speech to mean really, really little. You hear of nanotechnology and you just think that's really little. A nano is 1/1000th of a micro, 1/1,000,000th of a milli, and 1/1,000,000,000th of a basic unit. Or another way of saying that is there are 1,000,000,000 nanometers in 1 meter. And even smaller than that, 1,000 times smaller, is the pico. The pico is 1,000 times smaller than a nano or there are 1,000 picos in a nano. There are 1,000,000 picos in a micro. There are 1,000,000,000 picos in a milli, and there are 1 trillion picos in your basic unit. So there would be 1 trillion picometers in 1 meter. When you're looking at these, again, just like I said that there are prefixes between kilo and mega, there's obviously prefixes between milli and micro and nano and pico, but we're not going to worry about them because we really don't use them a lot. Similarly, if you look at the part of the scale you're used to from kilo to milli, we're really not going to use hecto or deca or deci or even centi that much this year. We do use centi a little. In medicine, they often talk about centiliters. In volume, we'll talk about cubic centimeters. And so kind of keep centi in your prefixes you need to know, but it's okay to let hecto and deca and deci go as far as chemistry is concerned. I have them in there now because you're used to them, and they do show that there's 10, that each one is 10 times greater or smaller, and so that's how you get to the 1,000 on either side. So let's look at converting between metric units. Let's take the quantity 32.02 grams and figure out how many milligrams that is. The first thing you need is a conversion factor, or a set of numbers that compares grams to milligrams. And there's two ways you could look at that. You could say 10 to the negative 3 grams is 1 milligram. Or 1 milligram is 1/1000th of a gram. 10 to the negative 3 is 1/1000th. Or you could flip it around and say 1 gram is 1,000 milligrams. And it doesn't matter which one you use. I'm going to show you calculations with both. And if it confuses you that you could use either one, I encourage you to actually try it on your own calculator. Use the one that makes the most sense to you. So the way you do this, and again, this should be review for many of you, although some of you have struggled with it in the past. In math, they call it the factor label method. I simply call it converting between units. So you have 32.02 grams, and then you put in what's essentially fractions. In AP chemistry, a lot of times they call them railroad tracks because they kind of look like railroad tracks, especially if you've got a number of them in succession. If I were doing this on paper with a pen, I would simply use fractions here, but to be honest, it's easier to do it this way on PowerPoint, so that's why I have the railroad track method. So then I'm going to pick my conversion factor. I like the bottom one. 1 gram is 1,000 milligrams. It just makes sense to me. And I want to cancel out my grams, so I'm going to put the 1 gram on the bottom, because if you remember from multiplying fractions, you can cross-cancel. So 1 gram equals 1,000 milligrams, which means because 1 gram and 1,000 milligrams are the exact same amount, you're essentially multiplying the 32.02 grams by the number 1, because anything over itself is 1, and 1,000 milligrams is a gram. So what we're doing when we're converting, and I think this makes sense on the surface, but when you really stop to think about it, it's maybe a little more complex, is we're not changing the quantity at all. We're simply changing the lens that we're looking at the quantity through. So our grams cancel, leaving us on the top with milligrams, which is what we wanted. And then, of course, we multiply across the top and divide across the bottom, but that's just 1. So 32.02 times 1,000 gives us 32,020 milligrams, or 3.202 times 10 to the 4th milligrams. We have 4 significant figures because the 32.02 is 4 significant figures. Remember, we don't use the 1 from the 1 or the 1,000 because those are exact quantities. And as we talked about, they therefore have unlimited significant figures, which, as we said earlier, means we're not going to count them when we're figuring out how many significant figures to use. If the 10 to the negative 3, or 1/1000th of a gram equaling 1 milligram makes more sense to you, that's what works in your head, you can work that calculation, in which case you're doing 32.02 times 1 divided by 10 to the negative 3, or 1/1000th. Again, your grams cancel, and you can see that you get the exact same number. And so that's where I would say, if that's not really obvious to you, and we all have different levels of comfort with mental math, get out your calculator and actually try it to show you that it's the same. That's how you're going to get more comfortable. Let's take one that's just a little harder. Let's look at 12.45 meters and how many nanometers that is. So again, we're going to need some conversion factors. We're going to start with 12.45 meters. And let's say I don't know off the top of my head how many meters are in a nanometer or vice versa. I would have trouble doing that. I have kind of a system that I use. But I do know how many meters are in a millimeter. So I can say there's 1 meter equaling 1,000 millimeters. So my meters cancel. So now I can go from millimeters maybe to micrometers. I know that's the next one down if you're kind of going in 1,000 increment chunks. So I go 1,000 micrometers in a millimeter. My millimeters cancel. Now I can go from micrometers to nanometers. And so I do 1,000 nanometers in a micrometer. My micrometers cancel, and I'm left with my nanometers. So because I have all ones on the bottom, this really involves just multiplying across the top. I would then divide by 1, which is the product of 1 times 1 times 1. Or I could do divided by 1, divided by 1, divided by 1, but that seems silly. And I end up with this number, which is 1.245 times 10 to the 10th nanometers. Again, the 4 significant figures comes from the 12.45 that was in the original problem. Let's look at a maybe quicker way to do that, or using less pencil lead. I could, if I happen to know that there's 1 billion nanometers in a meter, I can jump right there. And I'm not good at remembering that, 1 billion nanometers in a meter. But what I can do is I can write a 1 down, and then in my head I can say 1,000, so 3 zeros is going to get me to millimeters, 3 more zeros is going to get me to nanometers, and 3 more, to micrometers, and 3 more zeros is going to get me to nanometers, and then I have my billion. If that works for you, and you can do that, absolutely. Go ahead and kind of put that shortcut in. The meters cancel, you get the same answer. Similarly, you could say the 12.45 meters, and perhaps you know that 1 nanometer equals 10 to the negative 9th meters. If you'll notice on the above one, there's 9 zeros. Similarly, if you look at the top one, between the 3 conversion factors, we have 9 zeros, meaning there's 1 billion nanometers in a meter, or 1 nanometer is 1/1 billionth, or 10 to the negative 9th meters. And again, your meters cancel. You're going to get the same answer. Once again, I encourage you to try this on your calculator if you feel like you're kind of stumbling along through this. Let's look at converting between non-metric units. 12.2 feet is how many centimeters? Now you may need to look up some of these conversion factors. I'm going to start with 12.2 feet. And I don't know how many feet are in a centimeter or vice versa, but I do know that there are 12 inches in a foot. So that's going to help me cancel out the feet here. I also happen to know how many centimeters are in an inch. And this is something you should probably start to remember, the centimeters in an inch. And I know there's 2.54 centimeters in 1 inch. So the inches then cancel. So now again, to do the math, I can multiply across the top 12.2 times 12 times 2.54, and then divide through the bottom divided by 1, which is the product of 1 times 1. And that's going to give me 372 centimeters. The 3 significant figures come either from the 12.2 or from the 2.54. 2.54 is not an exact measurement, it's rounded. And so we would count it in the significant figures, but 12.2 is the same anyway. So either way, you have 3 significant figures. So let's look at 33 seconds is how many weeks. And I did this one because so far everything we've done, we've ended up with only ones in the denominator. And I want to show you a case where you might have ones in the numerator. So we start with 33 seconds. I know there's 60 seconds in a minute, and that's going to cancel my seconds. I know there's 60 minutes in an hour. That's going to cancel my minutes. I know there are 24 hours in a day. That's going to cancel my hours. And I know there's 7 days in a week, so that's going to cancel my days. Now in this case, except for the 33 seconds, everything ends up in the denominator. Not everything. Obviously 1 is a number, but 1 doesn't change the quantity when you're multiplying or dividing. There are problems where you're going to have numbers other than 1 in both the denominator and the numerator. So that's where it's really helpful to remember how to multiply by fractions. So here I can multiply across the top. 33 times 1 times 1 times 1 times 1 is 33. And then divide across the bottom. Divided by 60, divided by 60, divided by 24, divided by 7. And that ends up being 5.5 times 10 to the negative 5 weeks. Two significant figures, because 33 has two significant figures. All of the rest are exact conversions. One of the things to keep in mind is you can divide by the numerator in two different ways. You can do 33 times 1 times 1 times 1 times 1. And then you can say divided by 60, divided by 60, divided by 24, divided by 7. Or you can do 33 times 1 times 1 times 1 times 1 divided by the product of, so multiplying 60 times 60 times 24 times 7 together first. So if you are good at using parentheses, that can work on your calculator, or you can just divide each one through. Try both to again prove to yourself that it really is the same thing. Now I want to introduce an amount term to you. So a vocab word that when we say it, it means a certain amount. So like if I say a pair of shoes, I'm talking about 2 shoes. Let's start with a dozen. And I'm starting with a dozen not because I think I'm teaching you anything. I assume most of you know what a dozen of something is. A dozen, as we know, is 12 of something. We have to know what the something is before we know what that dozen is going to look like. You can't say, can you run a dozen? Because, run a dozen what? If somebody says, can you run a dozen steps? Yes, I can run a dozen steps. Somebody says, can you run a dozen miles? That might be something that's a little harder for me to do. I probably could, but certainly not in the amount of time it would take me to run a dozen steps. So the something is important in really knowing what this dozen looks like. 1 dozen cheetahs would be 12 cheetahs. 1 dozen sand fleas would be 12 sand fleas. Now, what's important about this is that it's the same number of cheetahs as sand fleas, but cheetahs take up more volume than sand fleas, and they're more massive. So a dozen cheetahs is going to have a much larger mass than a dozen sand fleas. A dozen cheetahs is going to take up a much larger amount of volume, amount of space, than a dozen sand fleas. So again, saying, hey, can you put a dozen in your car? A dozen what? That matters. I don't know about density because I don't know the density of a cheetah versus a sand flea. I'm not going to worry about that. But the point I'm making is, simply because you have the same number of two things doesn't mean you have the same volume or the same mass of those things. And then I think we can work outward and say 2 dozen cheetahs then is 24 cheetahs. 3 dozen cheetahs would be 36 cheetahs. Hopefully we're all on board. That's the idea of a dozen. So now here's the new term, and that's a mole. A mole in chemistry is 6.02 times 10 to the 23rd of something. And there's a reason for why it's 6.02 times 10 to the 23rd. I'm not sure it's in your book, but if you remind me, I can explain it in class why it's that number. If you want, get a piece of paper and write out what that looks like. Move that decimal point over 23 spaces. That's a big number. We know that you can't see an atom, one atom of something, but you could see a mole of something. So that means if I have a mole of cheetahs, I have 6.02 times 10 to the 23rd cheetahs. If I had a mole, 1 mole of lithium atoms, I have 6.02 times 10 to the 23rd lithium atoms. obviously if I have 2 moles of lithium atoms, that would be 12.02 times 10 to the 23rd lithium atoms, or 1.204 times 10 to the 24th lithium atoms. If I had a mole of gold atoms, I have 6.02 times 10 to the 23rd gold atoms. Now the reason I used lithium and gold is for the same reason I used cheetahs and sand fleas in the dozen example. I think everybody's very clear that cheetahs are bigger and more massive than sand fleas. What some of you know and some of you don't know is that gold atoms are larger and more massive than lithium atoms. So a mole of gold atoms is going to have a higher mass and take up more volume than a mole of lithium atoms. Just like with the dozen, that saying you have a dozen without knowing a dozen what doesn't tell you anything about volume or mass, the same with a mole. You're going to have the exact same number of lithium as gold atoms, but that chunk of gold is going to have a higher mass and a larger volume. Please remember to put any questions on the comment section and come to class tomorrow prepared to use this stuff in class.